The primary and secondary immune response. The immune response to invader like virus, bacteria can be divided into two phases: the primary immune response and the secondary immune response. These phases differ in their speed, intensity, and effectiveness in fighting infection. In primary immune response, this occurs when you encounter a new antigen foreign substance for the first time. Initial lag phase, it takes time for the immune response to recognize the antigen and mount a specific response. This lag phase can last several days or even weeks. Activation: B and T lymphocyte immune cells are activated by the antigen. Clonal expansion: the activated B cell and T cell undergo rapid replication, creating a large army of cells specifically tailored to fight the antigen. Differentiation: some of the B cells differentiate into plasma cells, which are antibody factories. These start producing antibodies, specialized protein that can bind to antigen and neutralize it. Gradual rise in antibody level: the level of antibodies in the blood gradually increases as more plasma cells are produced. Eventually, control of the infection: the antibody gradually bind and neutralize the antigen. And this is the main function of the antibody, eventually bringing the infection under control. Formation of memory cell: importantly, some B and T cells differentiate into memory cell. These cells remember the antigen and can quickly launch a powerful secondary response if the same antigen is encountered again. The secondary immune response: subsequent encounter: when you encounter the same antigen again after a period infection or vaccination. After or period infection or vaccination, the immune response react much faster and stronger. No longer face memory B cell and T cell from the first encounter rapidly recognize the antigen. Rapid activation: these memory cells quickly become activated by passing the initial lag phase seen in the primary response. Swift antibody production: memory B cells quickly differentiate into plasma cells, leading to the much faster and more robust production of antibodies specific to the antigen. Stronger and faster defense: higher and faster antibody production effectively neutralize the antigen, leading to quicker and more efficient control of the infection compared to the primary infection. Primary response. Benefit of the secondary response: faster and stronger. The secondary response is significantly faster and more effective than the primary response, leading to quicker control of the infection and minimize potential damage caused by the pathogen. Long-lasting immunity: the response of the memory cell provides long-lasting immune against the specific antigen, reducing risk of reinfection or mitigating the severity of subsequent infection. Vaccine work by mimicking the secondary immune response. Vaccination introduced a weakened or inactivated form of antigen into the body. This triggers the formation of memory cells, allowing the immune system to mount a rapid and effective secondary response if exposed to real pathogen later in life. Here we found the primary immune response and secondary immune response days of imagine antigen A, and this is the days till 72 days, and this is the antibody titer in serum. The response of antigen A in the first primary response and the secondary response. Here we find the difference between the antibody titer in here and there. Also, if the body exposed to antigen B, also the response differ from the primary and secondary response. the second response is faster and stronger, no lag phase. And also this is the idea of vaccination. We expose the body to the antigen and the body produce memory cells. When the real challenge by infection come, the body is prepared to fight, to produce antibodies strongly and effectively and specifically to this antigen, and it can reduce the damage and reduce the bad effect of this antigen or virus or bacteria.